So now that we know what a polynomial function looks like and how we can use its zeros to help us sketch a graph, let's get a little more specific. What if we don't know all of the zeros of a function? What if I give you a function and I give you maybe one of them, one of their zeros, but not everything, and I ask you to find the rest of them and then sketch? And we'll probably do that here too. So how can we use what we know to find the others? This is where synthetic or long division comes into play. So if I give you a specific zero, I would like you to divide out the given zero of the function and then solve what's left, which will probably involve some factoring and then some setting equal to 0 to solve. Okay, now remember, if something is a given 0, that means it came from a factor of that polynomial. So if something has come from a factor of that polynomial, there should be no remainder when we divide it out. So that's one thing that you can look out for. When you do your division, whether you choose synthetic or long, you should have no remainder if I had actually given you a 0 of the function. Okay, so just a nice little check there. So for this function, I've given you that 2 is a 0 of this cubic function. And I'm supposed to find the remaining zeros. I want you to find the remaining zeros. So we're going to find the remaining zeros, right? Now, if I have given you 1 0 of a cubic function, you have to think, how many zeros are we missing? Remember, the exponent determines how many zeros there are, whether they're real or imaginary. So if I have 1 here, that means we're missing 2. So just keep that in mind. We're missing 2 zeros. Okay, so again, I want to divide out this given 0, and then we'll see what's left that we can solve. So if I've given a specific 0, I'm going to use synthetic division because I have much fewer places to make mistakes with synthetic division. Remember, the 0 goes in the box. So it would have come from a factor of x minus 2, and so therefore the opposite number goes in the box. Okay, so don't switch the sign on the 0. That is the value in the box. Off to the right, I'm going to put my 3 and my 12, -9, -54, just pulling out my coefficients. We'll do a little synthetic division. So 3 drops, multiply with the 2 to make 18, multiply with the 2 to make 36, add together, what's that, 27, multiply with the 2 to make 54, and I get a 0. So there's that remainder of 0 that I was saying we should have. Okay, this should go evenly because it's a 0. Now, what does that mean about the 3, the 18, and the 27? Well, if we started with an x to the third, and we've divided out an x, I now have an x squared, an 18x, and a 27. So this is the remaining expression that we now need to solve. See how it's a square, and we know we're missing 2 of the zeros? So this is now what I want to set equal to 0, and let's solve. I'm seeing that there's a 3 in common here. So I could factor out a 3 as my GCF, or because this whole thing is equal to 0, why don't we just go ahead and divide out that 3? It's not going to affect the zeros of our function at all. It's just the stretch, right? So let's just divide it out of that equation. So now I can say that's x squared plus 6x plus 9 equals 0. And let's think about factoring it. Does this factor? Are there any numbers that multiply to be 9 that then add to be 6? And I'm thinking 3 and 3. So I could say x plus 3, or x plus 3 squared. And once we're factored, we set those equal to 0, and I'm seeing actually 2 remaining zeros of -3, because it happened twice since it's the same factor. So I'm going to say x equals -3 with a multiplicity of 2. So if we were to graph this, and let's go ahead and just do a quick little sketch in the tiny little bit of room that I have left. I know it crosses the x-axis at 2. I gave you that one. It crosses the x-axis at -3. It was a cubic, so we know the shape of a cubic with a positive leading coefficient. Right side is up, left side is down. But remember that multiplicity of 2 means at -3, it's bouncing off that x-axis. We should see a little parabola happening there. So y-intercept, if we put 0 in for all of our x's, is just -54. So it's a really deep one. Not going to worry about it. And then it goes up through. Okay, so just a quick little sketch based on all that information we know. So that's great if I give you a 0, or if you know one. But what if you don't? So like looking ahead to this next problem, I want you to find all the zeros of this big old function. And I haven't given you any to start with. So what do we know about this function? We know it's a fourth degree. We know it has a leading coefficient that's negative. So it's probably some sort of parabola type thing, but it's heading down. And it could cross the x-axis 4 times, unless we have some imaginary zeros. But where do we even start? Like, can you factor this? I feel like I could factor out a -2, but then again, I'm kind of stuck. I can't do any grouping because there's 5 terms. I mean, so really we're stuck. This isn't something I feel comfortable factoring. So let's just look at the graph. Let's grab a calculator and let's see what the graph will tell us about this function. So if you don't know any zeros of a function and you can't factor it, let's start by graphing it. On the calculator. And let's see what the calculator tells us. Okay, so I'm going to pull up my calculator, clear out this stuff. Let's see if I can squeeze it in. So y equals, maybe I'll do this. There we go. Y equals, I'm clearing out my old equations, -2x to the 4th minus 2x to the 3rd minus 6x squared minus 18x plus 108. Now, as we graph this, if we see 4 x-intercepts, we're golden and we have no additional work to do. If we see less than that, then that just means we've got some work to do. Okay, so here's our function. I could zoom out some, but I'm guessing that my only x-intercepts are already right here on my screen. Okay, and if you want to do a little investigating, we can go to second calc and we can pick out 0. But it looks to me like this function is going straight through the x value of -3, and it's going straight through the x value of 2. Okay, so let's go ahead and just assume that those are true. And if they were off a little bit, I would use my calculator to find them, but I think they're right there. So from the calculator, we saw x equaled -3 and x equaled 2. So that was our start by graphing on the calculator. And now it's just like the previous problem. Now we've got a value to use. Actually, we have 2 of them. Let's divide them out, and then we'll solve what's left, because we're still missing 2 of the zeros. Okay, so if x equals -3, -3 is going in the box. I'm going to use some synthetic division. My function was -2x to the 4th, -2x cubed, -6x squared, -18x, and 108. Now, I have 2 zeros. It does not matter the order in which you choose to divide them out. Okay, you should get a 0 remainder no matter what. Okay, order doesn't matter here. So -2, multiply those together and add, multiply those together and add. -18 times 3 is -54. Ooh, add those together. This isn't working. -2, -3 is 6, 4 times -3 is 12, -18 times 3 is +54. There's my mistake. I knew it wasn't working because I knew I wasn't going to get a 0 over there. So that's a +54. Gives me a +36. There we go. 36 times -3 is -108. Remainder 0. Perfect. So yes, -3 was actually a 0 for us. I got a remainder of 0, but we're not done. We have a second 0 we're going to divide out. Here's the key. Don't start over. Pick up where you left off. So now I'm going to take this row of numbers, treat them as my coefficients, and let's put 2 in the box and divide it out of just those. Okay, so build on with all of your division. Don't start over. So again, -2, multiply those together and get -4, 0, 0 times 2 is 0, which makes -18, times -36, and 0. And look, another remainder of 0, because 2 was a 0. Okay, so let's think about what we have left. We started with an x to the 4th. Our first answer would have been an x cubed. So that means this final answer is an x squared. 0 x's minus 18. So that's what we are now going to solve to find our remaining 2 zeros. Okay, so I'm just going to add over my 18. So -2x squared equals 18. Divide out that 2. So that's -9. And then I'll take a square root. So x equals, don't forget your plus or minus. This is where we'll get those final two answers, right? Now, square root of -9. We know we can't take a square root of a negative without using an I. So I know there's going to be an I in my answer, and the square root of 9 just becomes 3. So our final two zeros are plus or minus 3i. So in knowing that these are imaginary, it should make sense we didn't see them on the graph. Imaginary zeros don't show up on that graph. Only the real ones do. We have to use the real ones to find the imaginaries.